Students, welcome to Saurabh's classes. So in today's video, we'll be solving a question from macroeconomics. So in today's video, we'll be solving a question from Solow model. So in this question, it is given, consider a standard Solow model in discrete time with the law of motion of capital is given by K bracket T plus 1 equals to 1 minus delta KT plus IT. So as you can see, the law of motion of capital is given by this equation. Now here IT is investment at time t and KT is capital stock at time t. Now it is also given the capital stock depreciate at rate delta, which belongs to 0 to 1. So we have to remember what that is the capital stock depreciate. It is capital stock that depreciate at what rate? It depreciate at the rate delta, which belongs to 0, 1. Now suppose the output, which is denoted by YT, is augmented by government spending GT. So YT is augmented by government spending GT in every period. Now that the economy is closed, so we have to remember what the economy is closed. Now what's the difference between closed and open economy? In open economy, we would usually consider another term, which is NX, or you can also call it net export, which is given by X minus M, that is export minus import, which is known as net export. So but in closed economy, we usually consider the consumption, investment and government expenditure. Now we'll go further into solving this question. So here the equation is given as YT equals to CT, which is the consumption function, IT, and finally the government expenditure, which is GT. Now here CT is the consumption at time t. Now imagine the government spending is given by GT equals to delta of YT. So government spending is basically given by GT, which is equals to delta into YT. So now in the first question it is asked that suppose the CT is equals to 1 factor into YT, where lambda belongs to 0 to 1. Now we have to derive the effect of higher government spending in the form of higher delta on steady state equilibrium. So first of all, we need to mention the steady state equilibrium, which usually looks like this. This is the depreciation curve and this is the production function, or we can also denote it by YSFK. So where they both intersect with each other, we get the steady state level of capital, which is usually denoted by K star. Now we'll get into the solution of this law of motion of capital problem. So now let me insert another page. So in the question it is given KT plus 1 equals to 1 minus delta KT plus IT. So we already know in the question it is given. So here investment function is given as IT. Now if you further solve it, you will get the YT to be equals to CT plus IT. We know the income is equals to consumption plus investment plus government expenditure, which is denoted by GT. Now in the question it is given GT is equals to delta YT and CT is equals to phi minus theta t YT. So now we have to solve it for KT plus 1. So all we have to do is we simply have to put the value that it is given in the question. So now if you do so, you will get the value to be 1 minus delta KT plus YT minus CT minus GT. So now if you further solve it, you will get the value to be equals to 1 minus delta. As you can see, if you solve this portion of the question, then you will get it to be 1 minus delta, and then it will be KT plus 1 minus phi. We are simplifying it, so it will be 1 minus phi plus lambda delta minus delta YT. So now if you further solve it, you will get it to be 1 minus delta KT (1 minus phi minus delta 1 minus lambda function of K comma T). Now as we all so we know at steady state K star will be equals to KT, which is equals to KT plus 1. So in steady state we know K star will be equals to KT equals to KT plus 1. Now if you simply put the value here we have found, which is the value of KT plus 1, you will get it to be equals to K star equals to 1 minus lambda K star plus 1 minus phi minus delta 1 minus lambda function of K star. Now from here we can simply find the value of K star, which will be equals to 1 minus phi minus delta 1 minus lambda function of K star. So which will be divided by, this term will come on the right hand side, it will be this by delta. So now what we can do is we can simply differentiate this K star function with respect to delta first. So if you differentiate this K star function, which will be dk star by d delta, you will get it to be equals to lambda function of K star divided by delta plus 1 minus phi minus delta 1 minus lambda divided by delta function of, so f dash K star dk star by d delta. So now if you solve it, then you will get the value of dk star by d delta to be equals to delta minus 1 minus phi minus delta 1 minus lambda divided by delta function of f dash K star, which is equals to f K star lambda divided by delta. So if you further simplify it, you will get the value to be equals to lambda function of K star divided by delta minus 1 minus phi minus lambda 1 minus delta into 1 minus lambda, which will be into f dash. So here as you can see it will be f dash K star. Now assuming that, if you assume it to be, assuming delta to be less than 1 minus phi minus delta 1 minus lambda, here f dash K star will be greater than 0. So delta K star divided by d delta will be less than 0. So now if you refer to the question, here the steady state equilibrium rate effect of higher government spending will be negative. As you can see here, it is less than 0, so we would conclude the effect will be negative. Now we'll go to the next part of this question, which is question B. So in question B, first of all I'll refer to the question. So in this question it is asked that does a higher delta lead to a lower value of capital stock in the every period along the entire transition path. So we have to prove this claim. So for this reason we can simply state that yes, a higher lead to a lower value of capital stock in every period. Now let delta hat is greater than delta for sigma, the law of motion capital, the law of motion capital is equal to kt plus 1, as we have already talked about this thing. So here the capital T plus 1. So here kt plus 1 will be equals to 1 minus sigma kt plus 1 minus phi minus 1 minus lambda delta. So here fkt. So we have this so far. Now if you further solve it, we know the law of motion capital is basically k dash t plus 1 equals to 1 minus delta k dash t plus 1 minus phi minus 1 minus delta function of k dash t. Now so here what you can see is that we already have this. Now starting from, now if we start from k0 equals to k dash 0, we need to show that kt is greater than k dash t for all t greater than 1. Now we'll first show that k1 is greater than k dash 1. Now for this what we can do is we can simply write k1 is equal to 1 minus delta k naught plus 1 minus phi minus 1 minus lambda sigma function of k naught. Now if you, which will be obviously greater than 1 minus delta k0 plus 1 minus phi minus 1 minus lambda phi dash, which will be function k naught. So now it will basically be equal to 1 minus delta k naught 0 plus 1 minus phi minus 1 minus lambda phi dash, the sigma dash function of k dash 0, it will be equals to k dash 1. So now supporting this we can simply find kt to be greater than k dash t. So therefore higher delta, so we can say therefore delta lead to a lower value of capital stock, a lower value of capital stock, lower value of capital stock in every period. Now one thing we need to be careful about is that how will be the case when, so here let me insert a page. So now we'll check the case for kt plus 1, kt plus 1. So here k dash t, the value of k dash t we have to find out. For this first of all we'll start with kt plus 1. So just like the way we did it with KT, we'll do the same with KT plus 1, which will be equals to 1 minus sigma KT plus 1 minus phi minus 1 minus lambda delta function of KT. So now it will be greater than 1 minus lambda K dash T plus 1 minus phi minus 1 minus lambda sigma hat, which will be a function of K hat T. Now if you further simplify it, you will get the value to be equals to function of K dash T plus 1. So we can easily say from here that the higher sigma will lead to a lower value of capital stock in every period. So I hope you guys have understood it. If you still have any query or doubt, you can simply WhatsApp me on this number, which is 9836793076, or you can also go to our website, which is www.showropsirsclasses.com. There you will find a lot of other videos like this, and you will also get to see a lot of other materials which are needed for different entrance exam. So thank you for watching this video. If you have any query or doubt, you can simply WhatsApp me at any time. Have a nice day ahead.